In this example, let C equal the matrix P3, 12P, where P is an element of the real number system. For part A, we want to calculate the determinant, which is det C. To do this, we're first going to label the entries in the matrix A, B, C, and D, because we need this to calculate the determinant. So we know that the determinant of a matrix is equal to A times D minus B times C. So for this matrix we have A, which is P, times D, which is also P, minus B, which is 3, times C, which is 12. So the determinant is P squared minus 36. For part B, we're asked for what values of P does the inverse of C not exist. And we know the inverse of C will not exist when the determinant of C is equal to 0. So that means we're solving P squared minus 36 is equal to 0. So if we add 36 to both sides of this equation, we find that P squared is equal to 36. Therefore, P equals plus or minus the square root of 36, which gives plus or minus 6 as the values of P for which the inverse will not exist. For part C, if P equals 4, calculate the inverse of C. So if P equals 4, we can write C is equal to 4, 3, 12, and 4. So if that is C, we know that C inverse is equal to 1 divided by AD, which is 4 times 4, minus BC, which is 3 times 12. And then we swap the positions of A and D, so we have 4 and 4 still, and then we multiply the positions of B and C by -1. So that will become -3, and that will become -12. So simplifying this down, the inverse is going to become 1 divided by, and we're going to have 16 minus 36, which will be -20, and then inside our matrix remains the same, so we have 4 minus 3 minus 12 and 4. So that is the inverse of the matrix C when P equals 4.